Hello, my name is Hassan. In this video, I would like to show you another example of finding the derivative of a function. Specifically, I would like to show you how to find the derivative of sine of x. For this purpose, I'm going to prove two helpful theorems before that. The first one is the following. Limit of sine of alpha divided by alpha as alpha goes to 0 is equal to 1. The second theorem I'm going to need and I'm going to prove is limit of cosine of alpha minus 1 divided by alpha as alpha goes to 0 is equal to 0. So I'm going to need these two theorems, so I need to prove them first. Let's prove the first one. We need to draw a unit circle, and we need to show an angle of alpha here. I'm going to section this into three different areas. So I'm going to plot three different areas here. The first one is the area of this triangle from O, A, B, of this one. And the second area will be this circular slice, OAB. And there's going to be a third area, which is going to be OCB. And for this third area, the CB is perpendicular to OB. Now let's find these three areas. The area 1, which is the triangle OAB, is basically the base times the height divided by 2, because it's the area of this triangle. And as you can see, the height is going to be equal to the sine of alpha. Sine of alpha times the base is going to be OB, which is 1, divided by 2. The reason why this is sine alpha is because this is unit sphere, which means OA is 1, and also OB is 1. So that's how we found it. So it's half the sine of alpha. The second area, A2, is going to be the slice OAB, which is, if you think about the entire area of the circle, it's going to be pi r squared, which is pi for the unit circle. So, but we are going to take a slice of alpha degrees or alpha radians. So it's going to be alpha divided by 2 pi times the entire area is pi. So we are taking basically 1/2 pi of alpha. And this is going to give you the area as alpha divided by 2. This is the area of this slice OAB. Now the third area, A3, is going to be the area of the third triangle. This is OCB. Since CB is perpendicular to OB, and since OB is 1, the area is CB divided by 2. But CB is nothing but the tangent of the alpha angle. So it's tangent alpha divided by 2. This is the third area. So we can write down the inequality of for these three areas. As you can see, A1 is less than or equal to A2, and that's less than or equal to A3. If you write down these areas, it's going to be sine alpha divided by 2 less than or equal to alpha divided by 2, and that's less than or equal to A3, which is tangent alpha divided by 2. I need to mention here that alpha values are positive, as I show in this figure. So this inequality is true for the positive values of alpha. But you can write down the same type of inequality for the negative values of alpha. But for either case, the absolute values of the areas are going to obey this inequality. So what can we do right now? We can multiply with 2, so we get sine alpha less than or equal to absolute value of alpha, and that's less than or equal to tangent alpha, but instead of tangent alpha, I'm going to write down sine of alpha divided by cosine of alpha in absolute value. And you can divide the absolute value of sine of alpha this and this, so you find 1 less than or equal to alpha divided by sine alpha less than or equal to 1 over cosine alpha in absolute values. We can take the reciprocal of these 3 expressions, but we need to change the direction of the inequality like this. 1 is going to be greater than or equal to sine of alpha divided by absolute value of alpha, and that's larger than or equal to cosine alpha. So we are getting pretty much close to proving this result. What we are going to do is we're going to apply the Sandwich Theorem as I shown before. So if we have an expression which is less than or equal to some expression and larger than or equal to another expression, and if the limits of the 2 expressions on the left and the right are the same, then the limit of this expression is the same as the limit of these expressions. Okay, in summary. So if you take the limit of sine of alpha divided by alpha as alpha goes to 0, that's equal to 1, because the limit of the left-hand side is 1, because it's a constant, and limit of cosine alpha as alpha goes to 0 is also 1. So the limit of these 2 expressions are 1. So these 2 expressions approach 1. That means this expression should also approach 1, because that's in between these 2 values. So we have shown that this holds, but with a slight difference. These sine alpha and alpha should be in under absolute value signs. So, but you can clearly see that if you approach 0 from right hand side, this exactly equals to this one. And if you approach 0 from the left hand side, alpha is negative, and that means sine alpha, the absolute value of sine alpha is minus sine alpha, and absolute value of alpha is minus alpha. Then the minuses cancel, and it's exactly the same as this expression. So this goes to 1 no matter you approach 0 from the right or from the left. So hence we can say that limit of sine alpha divided by alpha is equal, as alpha goes to 0, is equal to 1. So we have proven the first expression. What about the second expression? Okay. For this one, we need to write down the following expression. Cosine alpha minus 1 divided by alpha is equal to. I'm going to write down the cosine alpha in terms of the half angle expressions, half angle identities, which means that I'm going to, instead of cos alpha, I'm going to write cos 2 times alpha divided by 2. I'm writing cosine of something as cosine of twice half of it, because I'm going to convert this cosine expression into a sine expression. That's why I'm doing it. And that should be equal to 1 minus sine square of the angle which is doubled. which is alpha divided by 2. So let me remind you about it. So cosine 2x is basically equal to 1 minus sine square x. That's the expression that I used here. Then we have minus 1 divided by alpha. And plus 1 and minus 1's cancel. So we come up with the following expression. Minus sine square alpha divided by 2 divided by alpha. Instead of sine square alpha divided by 2, I'm going to write down sine of alpha divided by 2 times sine of alpha divided by 2. And I want to divide this to alpha here. And this expression has minus sign here, because I need to put minus in front of one of these two. And instead of alpha, I would like to write alpha divided by 2, and I want to multiply this with 2. So in the denominator, I have alpha, but I want to make this look like alpha divided by 2, so that the argument of sine and the denominator are going to be equal, so that I can use this theorem. So basically, if I take the limit of both sides as alpha goes to 0, this expression, limit alpha goes to 0, sine of alpha divided by 2 divided by alpha divided by 2 times minus sine alpha divided by 2 divided by 2. As we have shown, this expression should approach 1. And as alpha goes to 0, this expression goes to 0, because sine of 0 is 0, which makes this expression 0. So we have proven this expression. Limit of cosine alpha minus 1 divided by alpha as alpha goes to 0 is 0. Now, how are we going to use these two theorems to find out the derivative of sine of x? Let's do it. Okay, what is the derivative of sine of x? d by dx sine of x is equal to limit of sine of x plus h minus sine of x divided by h as h goes to 0, as I have told before in my previous videos. And instead of sine x plus h, we are going to write down the formula, the identity, trigonometric identity for that. It's basically sine of the first term times the cosine of the second term plus sine of the second term times cosine of the first term minus this sine of x divided by h. Now, as you can see, we have three expressions here, which is summed. But the first and the third has the common prefactor, which is sine of x. So if we take to the parentheses of sine of x, it's going to be sine of x in parentheses, limit h goes to 0. This is going to be cosine h minus 1 divided by h. And this another term is going to be sine of h times cosine of h divided by h plus limit h goes to 0, sine of h divided by h times cosine x. As you can see, this limit is 0, as we have shown before. And this limit of sine of h divided by h as h goes to 0 is 1, as we have shown before. So this expression is nothing but the cosine of x. So this completes our calculations. So in short, we can write that the derivative of sine of x is equal to cosine of x. Okay, so we have found the derivative of sine of x. Thank you very much for watching me. If you want to get notifications about my upcoming videos on calculus and physics, you can subscribe to my channel and push the notification button so that you can get notifications about my videos. Thank you very much for watching me.